Good evening. Time for more Haskell live streaming. I missed last week, unfortunately. Sorry about that. I haven't written much code recently either, so this could be interesting. I'm sure I can remember how to write code. Plan for today is to have a look at exceptions and error handling. In the previous episode I managed to do, I was trying to move some stuff into an abstraction for the stack, and lots of these things returned errors. So if you pop something, it might return an error if the stack is empty, or you try and jump back to a location, that can also return an error. And I did that by returning either types, and they're really hard to compose. Either types, I guess, on their own are quite straightforward to compose, but because I was returning a value inside there and quite often returning a tuple and trying to grab the first bit of the value out, it just became hard to compose. So what I might do today is have a look at Control.Monad.Except and look at exception handling and try and rewrite that code. Try to write the code using exceptions so that I can just write out the normal flow of what I want to happen when it goes right, and then wrap it all in some kind of catch thing. So let's take a look at the code. It's this piece of code that I was most worried about, I think. Well, this is the one that was most difficult. So we're trying to return from the stack, but it's a whole series of things. So we pop something, and that gives us a result and the rest of the stack. And then we call return, which kind of jumps the stack back. And that gives us a new stack. And then we pop it again, and this gives us a new stack. No, it doesn't. It gives us the address we want to return to, and another new stack. And then we finally do the thing. But obviously these things are just nested in case statements, and each one has to try and handle the error if it doesn't go well. I initially thought I could fold over the ethers, or just compose the ethers in some way. So I thought I could do something like Sarah prime, so that's going to go from CPU to CPU. Sarah prime. I need to grab all this stuff. Let's copy it. We're done. Okay, so I thought I could do something like get the value back. So we can call, what's the result, isn't it? And the S, and that'll be a tuple, and you can say that's something like s.pop CPU stack. Not equal. Could I have equal above? What am I doing here? So, and that'll be a let statement. In, and then the trouble with this is that this is an either type. So what I thought I could do is have a function which is something like, what am I thinking here? I thought I could take the popping from here, and I could feed it into the next function. So I think if I have an either type and I feed it into another function, it'll only call the function if it's right. So it's a successful return. It wouldn't call it if I returned left from pop. And you could have something which takes the result of popping backslash. So the result of popping is actually a tuple, so it's going to be something like result in S. And it would it would do something with that result. The trouble is that I could do that. So you have some kind of lambda here. And then we'd want to feed it into the next step. But that would, this function, this lambda, would need to return a growing collection of things. So it would need to return the result. And then whatever the next action was, the next action was calling return, and you get a new stack back. And a new result, actually. No, you just get a stack back at that point. But you'd need to somehow join that up with this result and feed it into the next function. And then the next function would need to pop, and it would need to have the original result and a new stack and another return address. So feeding it through this kind of thing is difficult because I'm trying to capture things as I go. So what I really want to do is say, in an ideal world, it would be we do it let for now. So result, and that is s.pop stack, and then we'd have some other clauses in there. So we might have, at that point, we can have s prime is s.ret of saying CPU SP and S, and then the return address and s prime prime is s.pop. This is a tuple again. It's s.pop of s prime. You can say in CPU, and then CPU IP is return address, and CPU stack is s.push result onto s prime prime. So the problem here, the first problem here, is that it's not giving me my helpful thing. There we go. So I'm trying to assign a tuple, but we have either string, int, and s stack. So this isn't going to work. So what I want to do is change I want to change this so that it returns a tuple or throws an exception. So to do that, I want to use Control.Monad.Except. I think that's what it's called. Port Control.Monad.Except. Not combinator's expression. Hidden package of MTL. Okay. So back to my file file, and not the calculator, not the test suite, but the library is going to rely on MTL. Okay, so now I have Control.Monad.Except. And by default, we'll import nothing. Where's my code? Okay. So at this point, if I go into stack, I'm just going to write a new operation called pop prime. It's going to be like pop, except it's not going to return an either. It's going to run under the except monad, I think. So we take a stack and we return however this works. I think I'm gonna have to look it up. So Control.Except. Oh, for some examples here. Got any nice examples? Yes, example 1. I can create custom errors as well. That might be a good thing to do. And we can then define show on those things. So we just call through error. That's all we need to do, I think. By the looks of things. And then we can do catch somewhere. Where is it doing catch? For result of calculate length returns. Throwing an error in this monad means returning a left. That's okay. What's this do? I got length monad here, which is accept t string IO. Sorry, this one. The monad was either length error or something else. Okay, so length monad, which is this thing, or an int. Okay, I can write this using throw error. So pop prime, right, bring that back. It was, I just defined that as being either whatever and then use through error. Either stack error, I'm going to define that so it's easier to use. Otherwise it returns an int in the stack. I'll just stick this in here for now. So data, stack error is empty stack. Or stack too small. I think something I have done here. Or invalid stack position. I'll do for now. Okay, and then pop prime. I'll get it this way, and I can say if this stack is empty, is through error. Empty stack. I should be able to import that. Oh, control monad error. Why the wrong monad? No, it's Control.Monad.Except. So it's either string. Let's find either string or either IO. If you're using the deprecated Control.Monad error, okay, so I just want to avoid Control.Monad error, I think. Did it give me an option though? Yeah. So I could use that one. Okay, and then we say pop prime of anything that's got a stack that contains x and x's. So here I think I need to still return right. That's annoying. It's not really what I had in mind. I thought it was a better example of this. Oh, it's return or pure, okay. But it's still going to be an either type. So I'm not sure how that makes it any better. So is that going to help at all? Stack error. Empty stack is empty stack and show of stack too small is not enough elements on the stack, and show of invalid stack position is whatever this thing was. And we can also export stack error. Okay, it's a bit out here. Show is not a visible method of class show. What is it then? What was that? Let's go back to example. Instant show blah where show equals that. Instant show stack error. I'm confused. I've no idea. Just derive it. Because that's not what I'm trying to fix tonight. Okay, so we have something that will, in theory, throw an error when I try and call pop on an empty stack. So I can import stack, and I can say S is an empty stack, and I can say pop S, and this is left pop empty stack, and then pop prime S is left empty stack. Okay. Doesn't seem radically different so far. So what can I do with catch error? Maybe that's the thing I'm more interested in. So you can do a bunch of stuff and then catch the error. The handler and the do block must have the same return type. Okay. So I go back to the VM. I'm just going to go CPU to CPU. I think the example of this was so it was do, then a whole bunch of actions, then catch error, and the handler. Oops. So it would be do, and then some stuff. So you'd say result S comes from S dot pop prime CPU stack. Just going to do, I've only written pop so far, and we can say something like return address, and S prime comes from S dot pop prime of S, and then I think I can say your CPU, and then we'll say CPU stack is S prime, like that. Result onto S prime. Okay. And then can you say catch error here? And then we just return CPU. Actually, not quite that. So you can say CPU where CPU error is something. I really want the error that came back from catching. That a thing I can do. Catch error. So a bunch of actions. E to MA. This whole thing would need to be under some kind of monad error, I think. Don't know. Let me start by moving this into function. Okay, so do go catch error, handle error, and handle error. I'm giving some error is CPU. We'll set CPU error the error we got back. Okay, so that one. Control.Monad. Add that. Let's go for that. Okay, so now we've got. Can we work out just the error alone? Can match CPU with actual type, either stack error or CPU. So we use that, doesn't work. If we put that in, and then we just fix type, so it's going to be either stack error or CPU. No. So I can match that with maybe string. Where's maybe string coming from? Give us some. I'll make some warnings the way. Okay, so we go back to the browser. Okay, where's browser? So this is catch error. Catch error example. This one maybe. Error using that. Nope, it's not quite the right one. This random example. So run that thing. And it's returning their monad, which is arity string identity. And so here we throw an error, which is a string. You have to catch the error, and they return a double in both cases. Oh, maybe not. So we're assigning it to a thing here. And then using that later on, where I just want to return one of these two. I think that should be okay. I think. Just want to see what it says here. So couldn't match the type of go. Okay, stop it. The type of go is s.stackError_CPU. So I change this to a stack error. Here, problem catch error. So this is the thing, we do some stuff. Do I need to move my do up to here? That doesn't help. Do some actions, catch the error, and call the handler. Where action functions can call throw error. The handler and the do block must have the same return type. So they just return CPU, but they can't, because that wouldn't be an action. And this presumably will complain because returning CPU and it wants either stack error or CPU. Okay, so now the problem is just with catch error. So catch error has got some type of MA, is a thing that we have for s.pop. E to MA, which is the handler. Take the error and we turn an MA, and the whole thing returns an MA. So it couldn't match. Stack error was maybe string. Functional dependency between constraint monad error maybe string. Monad error maybe string either the catch error. Monad error maybe string. Either stack error. But if we change this to be maybe string, it seems weird to put that inside neither as well. That's great, because this will return stack error. Let's find another example. Eight ways to report errors in Haskell. Monad in a file, monad error in a custom type. That's almost what we're doing. Yeah. Monad error in custom type. So they have, these are just some error types, and then they have throw error. And this is either custom error string, in catch error prefix, just to confuse things. So they're doing some stuff. Show queue is taking it, their error here, error from up here, and turn it back into string. Otherwise, they're returning the error. So in this case, they're returning the error, but I'm not returning the error. I am returning new CPU with the error set inside it. Okay, so I'm playing right catch error, aren't I? Monad error, catch error. I think that's what I want. Didn't put control on an error, but I think this was just saying it got deprecated. Very deprecated. Okay, so very confused by this. Oops, go back. Haskell Control.Monad.Except. It's one example of it. These just seem very vague. And these are just the docs I'm reading. A bit confused as why this is not working. So just jump to error, I guess. I'm a bit confused as to why it thinks it's maybe string. I can't work out where that's coming from. It's not part of catch error, it seems. And it looks like the example I saw in the 20 different ways of handling errors. So the example is catch error, but I've then fixed it. So I've got go, catch error, and then something which takes an error and returns a CPU. So they're both returning a CPU. I'm just really confused by this error message. Type of go, I think, is either s.stack error or a new CPU. Yeah, compiler agrees with me. And the type of handle error, I think it's the same thing. Ooh, it does not agree with me. Interesting. That's where maybe string is coming from. Okay. Couldn't much expect to type either stack error CPU with maybe string F0 CPU. So what's the type of the handler? Handler gets called with E. You see handle error as its own function. And we'll say this is of type CPU. I have this. So you can say CPU and CPU error is error. So this goes maybe string to CPU. Okay, so handle error goes from maybe string to a CPU. It doesn't, does it? It goes maybe string to s.stack error CPU. Either, sorry. So handle error, given some error, is the CPU from above with the error set to error and purify that. And this will work purely. Oops, maybe a string or CPU. That does not help at all. Pure CPU error is error. And then same thing, presumably. Yep. Okay. So let's try and do an example of this. So we could say not 0, given some x, and say if x is 0, then only Control.Monad.Except. It's bigger. Okay, so not 0 is of x. If x is 0, then through error, I want some custom error type, damn it. Okay. Zero error is 0 error. Okay. Now we can say not 0 again. Of x is if x is 0, then through error, oops, 0 error, else then we just return x, I guess. I'm going to say not 0 of 2 instance show where show everything. Okay, let's try it again. No instance for num m a 0. Okay. This is not helping at all, is it? Can we even just say catch error and then just return 966 for no particular reason. Now, reload. No, undefine everything. Let's just try this. Deriving show. Oh, and then it's just some kind of run thing. Maybe that's what I want to do. Run except of not 0, 2. Oh, I've cleared everything, haven't I? Wow. You cannot deduce equal blah blah 0 error from context. That's very confusing. No, this is really not helping at all. I'm even more confused. So I needed to create this thing as being either whatever, and then they return pure. Yeah, they use pure. Okay, let's try this again. So that pure. Okay, that's better. Can I just run it on its own? I cannot. Okay. So that's right too, and then we could say 0, left 0. Okay. We're trying to return a number. So can we say not 0 of 0 and then catch error? And it's a function which is given the error, which we'll ignore, and we return a number. So we'd say pure 66. And then run accept. Right, 66, okay. So that form of using catch error seems to be okay. So can I say what's the next thing I had? So we got the custom error thing going on. That should be exactly the same. This was returning a more complicated thing. But that shouldn't make any difference. It's just another type. It doesn't care what that type is. So if I bring this back, for a second, just say pure CPU, so we do nothing to it. Right. That's interesting. So I just do the CPU, it's fine. Oh my goodness, is it that? No. So I do pure CPU. That's an error, but when I write it out like this, it's not an error. Okay. Maybe that's okay, just pointless. And then can we do this? CPU error is error. This is a string. So it could be something like show error. No instance is string, maybe string. Oh, is it something really stupid? Is it because CPU error is a maybe type? just totally misunderstood the error message, I think. Is it? Oops. Is it as simple as just error? Not quite. So couldn't match type maybe string with string, expected string, got maybe string. And first we've just so confused now. Still upset with me. No. Couldn't match type CPU with that. So if I get rid of the pure again, no. Okay, so if we had a function which does nothing and returns pure CPU, CPU error is just an error, it seems happy with that. If I then capture this, and say just E, it doesn't like that. It doesn't like that. Weird, it's moving the error back to here. Oh, okay. Maybe I understand it now. So this E is not maybe string, it's stack error. Right. So I can say it is just show E. Look at that. Easy, right? Okay. So that lets me write out this kind of pushing and doing stuff. So what happens if I try and run it? It's not exported, is it? So I can't call it outside. I'm just going to briefly export it. Step ret prime compile REPL import CPU import VM. Okay, now I presume I can say step ret. What's the type of that? Okay. Can I say CPU is new CPU? Initial CPU? How do we create a CPU? Oh, we're not exporting it. That's great. Try reloading. Okay, we got one. So now we can say step ret. This has got an empty CPU. And I can say run either. Nope. Nope. Where does run either come from? Say run except. What's the type of this? EMA with either ERA. Doesn't take any arguments. I don't think it's going to work. Step ret prime of initial CPU. It's wrong types. Case that of okay, safe. What's in the either type? Is data either? But I don't think it's that I want, because I couldn't run that. I can say is left and is right, and from left. And from right. So I expect to get the left back. But I can start with is left, I think. It is not. Okay. Do right of that. There's no instance for show of the CPU. Okay. But it didn't return an error, which is confusing me. Okay. My understanding of Haskell's error handling is not great. If we just run step around some, what does that return? It returns VM.cpu. But actually we'd expect it to complain because the stack is initially empty. If you pop an empty stack, then it, unless there's a bug in my stack handling saying, what is the empty stack? No, the empty stack is this. could replace it though and say empty stack. No, I cannot. Oh, because empty stack is a function. But it should still throw it anyway. Oh, no, but the whole point about the step red is it catches it. That's what's always returning CPU, I think. Right, okay, so reload. Step right initial CPU. There we go. Okay, yes. Of course, because we always get CPU back, it's just the error is here. Okay, cool. I think that's okay. And then the other thing we could do is we could put a couple of things on the stack. So we could say like CPU stack is a stack containing 1 and 2. Oh, very annoying. Instruction. Okay, brings back in. Reload. Import stack. There we go. Okay, so error is nothing, and it's done some stuff. That doesn't work because the stack is empty. We try and pop off it. Yeah, so we're taking the first thing and putting it onto the remaining stack. Okay. Cool. So that's how I do it. Which means that in here, all of these, in fact, we could even just catch it at this level. We could just we don't need to catch it here. We just return this type. We can let these things throw. Then I can catch it here. And say there's an error, we'll return CPU. And then this is always going to be right. It'll be like either error CPU, but it's always going to be right. Okay, cool. I think. So, what have I learned today? Error handling is very hard. I think I have the basic pattern in place, so next week I can come back and look at this and try and tidy the code up a little bit. Feed the error handling into all of the stack things and then into all of the steps, and then catch the error at this level. I think that should work quite well. But it's going to be a bit of work. I'm not here next week. I'm away somewhere, but the week after I'll come back and I'll see if I can let lots of things return errors or throw errors and catch them all in this step, and then set the CPU error at that point if we get something happening. Cool. Okay. Thank you for watching along, and hopefully see you in a couple of weeks. Goodbye.